This is Unit 2, Equations and Inequalities, Lesson 8, Solving Compound Inequalities. Your objectives for this lesson is that you can solve a compound inequality and also graph its solution on a number line. Before we begin with this lesson, let's review a little bit of what you've learned so far. Let's make sure you understand the difference between an inequality and an equation. In each one of these problems, identify if it's an inequality or an equation with an I for inequality or E for equation. In the first example, we have the greater than sign. That would be an inequality. In the next equation or next sentence, we have a less than or equal to sign. Again, that's an inequality. In the next sentence, you have an equal sign, so that's an equation. And the last one, we have a greater than sign, so that again is an inequality. So the basic difference between an inequality and an equation is whether or not it has an equal sign. Let's make sure you remember the symbols and what they stand for. Greater than, that means that we have one side or a number that's bigger than the other. So you would use the inequality symbol that looks like this to show that it's greater than the other side. Less than or equal to is just pointing the opposite sign or the opposite direction. To also include a number, you would just simply put a line under it to show the equal to. And finally, greater than or equal to, go this way with a line underneath it, greater than or equal to. You've also graphed inequalities before. Remember that the direction of the arrow is saying all the answers for the solution. So if we said that X, or the line is representing, let me go back. So the dot is representing the endpoint, which it looks like our endpoint, well, we have a 0 and a -4. There's several numbers between 0 and -4. You have -1, -2, -3. It's not quite on -4, so I'm assuming that endpoint is at -3. And because our arrow is pointing to the right, we're going to make our inequality symbol also point to the right. It is left open, so I will not include the equal sign, and I'll put my X here. So that number line or that graph is representing all the values that are greater than -3. The opposite of that, notice that the dot here is colored in. We have still our endpoints at -3. Our direction is pointing to the left this time. It is colored in, so we would put the line underneath it and write your X here. So this graph represents all the values that are less than or equal to -3. Question 15, again, let's write the solution. On this one, if you read the directions carefully, all it wants to know is what is its endpoint and whether or not it's a solution to the inequality. So in the first example on 15, we have an endpoint that appears to be really close to -4, but between -4 and -8. So let's think of all the numbers that are between -4 and -8. You have -5, -6, -7. So I'm guessing this looks like it's at -4, or -5. Okay. With -5 as our endpoint, but it wants to know, is -5 also a solution to this inequality? Well, because our endpoint is colored in, you would say yes. If they want to know, it's not ready. If they want to know the reason why, then you say because the endpoint is open, or is closed. Endpoint is closed. And what do I mean by closed? It means that it's colored in. In the next example, we have an endpoint that's between 4 and 8, but pretty close to 8, so I'm assuming that that's at 7. But is 7 a solution? You would say no. And again, why? Because the endpoint in this case is open or not colored in. Let's make sure you know your words for the symbols as well, just in reverse. It says circle the words to complete the sentence. The solution of the inequality x is, what does that symbol stand for? It's greater than, get my pen, greater than. In question 17, underline the correct word or words to complete each sentence. The graph of x is, it says greater than -4, does not include -4. Why? Because there's no equal sign underneath it. The graph of x is greater than -4 will then have an open dot at -4. Therefore, in question number 18, to graph the solution of x is greater than -4, you have to find -4 on your number line. -4 would be between -6 and -3, so right here we have to leave it open. And our inequality is pointing to the right, so our arrow, when we graph it, should also point to the right. Don't forget your arrowhead on that. So here we're going to introduce you to a new word, compound. Compound inequality is much like compound sentences. In English, you have learned that two sentences can be combined, are called compound sentences. An inequality can also be combined to form compound inequalities. Let me give you an example. Okay, let's say you had two sentences. This is not on your paper, so you just might want to write this on your notes. Again, I'm sorry for the stylus, it's not letting me write to it easily. He went to the store, he bought bread. In English, if you had two sentences like that both had the same subject, you could have combined the two sentences together by saying, he went to the store and bought bread. Make sense? You could do the same thing with inequalities. If your x is the same in two inequality statements, you can put it together in one complete statement. For example, it says down here, example, you read, and you see the 3 is less than x, less than 6. The way you could read that is x is less than 6 and greater than 3. You read this from where the x is located in the inequality statement. See how it's in between the 3 and the 6? That's what you're also going to be graphing, is that all the values that are in between 3 and 6. Now in this statement right here is what it will look like. These are all called and statements. Okay. There's another way you'll see the word and actually in the two statements that you'll put together just like this, or you'll see the word or. But if you do not see the word and or, then you assume that this is an and problem. Okay, so you see how the x is less than 6, but then if you look at the x and where the 3's at, reading from x to the end point, it's x is greater than 3. Let's practice a couple of these. Let's look at the difference between and versus or. In an and statement, both sentences must be true for a solution to be true. So let's think of it in words here. If I had the phrase, the sky is blue and the grass is green, you would agree with both the sky is blue and grass is green, so therefore an inequality statement would be true. 6 is less than 12, well that's true, and 6 is greater than 2, that's also true. Because both of those statements are true, the inequality would be true. And our next example, if x is equal to 4, if x was less than 9, is 4 less than 9? True, but is x greater than 30? Well, 4 is not greater than 30, so that would be false. Because both of those statements are not true, then that means the statement altogether would be false if it was an and statement. In an or statement, though, only one of the sentences has to be true for the solution to be true. For example, the USA has 48 states or is in North America. Does the USA have 48 states? Well, actually, there's 50. But is it in North America? Yeah, that's true. So it didn't matter that there's less than 48 states, because one of those statements is completely true, the whole statement is true in an or phrase. In the next example, 9 is greater than 3. Is 9 greater than 3? True. Is 9 less than 10? True. Both statements are true, but only one of them had to be true. That means our whole statement with the or is also still true. And the next example says if x is equal to 2, then if x is greater than 9, well, is 2 greater than 9? No, that's false. Is x less than negative 3? That's also false. Because both statements are false, then the statement altogether would be false. Another way to think of an or statement, I always like to say, is think of walking into the Excel Center and you ask somebody where the bathrooms are at. You could say, well, there's bathrooms this way, and you point one direction or the other way. So what would that look like then on a number line? An and statement indicates all the numbers in between two endpoints, or in between a maximum and a minimum value. So for example, the age a person drives. Well, you have to be greater than 16. You actually can't get your driver's license on your 16th birthday, so that's why the circle is open. And I just picked a number, but less than or equal to 85 without having to get tested every year. So therefore, you can be 85 and drive, and they have it colored in. So the age in which you can drive is in between 16 and 85. So notice the two statements. We can write this in two different ways. And just a minute. Sorry, I lost connection for a second there. Alright, so we were looking at the two ways to write and statements. One way to write the and statement was actually with the word and. To write the same and statement where we're showing the x is in between these two values, what I'll do is after I graph it, I'll write my x in between the two endpoints like you see here in the graph. And then I see that I always point my inequalities to the left. So if you know that song, to the left, always remember your inequalities should be pointing to the left. But then I do draw the underlines if it's closed. For example, 85 is closed, so I'll draw the underline. And then I write in my endpoints, the 16 and the 85. So this is another example of a compound inequality and statement. Ors are a little bit easier because you will always use the word or. When you write these statements, your variable should always be on the left of the statement. So, for example, here they have the endpoint of 3, and they used A to represent the age that a person wears diapers. That's kind of funny. So they're saying under 3 years of age. So A is less than 3 because our arrow is pointing to the left. And A is greater than 70 because our arrow is pointing to the right. Do you see the joke there? And then you would have the word or. Or statements will always have the word or. So to help you out, and statements should always be pointing towards each other, where or statements should always be pointing away from each other. Let's make sure that you clearly understand what a compound inequality is then. Look at each one and let's cross off the ones that are not in compound inequalities. Here we have negative 2 is greater than x, or x is greater than 3. So we have two inequalities joined with the or statement, so that is an inequality. And the next example, x is greater than or equal to 0. I only see one inequalities, and we don't see an and or an or, so that is not a compound inequality. The next one, I see two inequality symbols, so therefore it is compound, and the last one is not, because it only has one inequality symbol. So it says cross out the ones that are not inequalities. That's what we did there. Problem 4, draw a line from each description in column A to the inequality it describes in column B. Okay, so let's see here. In the first example, I'm just going to number these real quick. There's 1, 2, 3 and 4. Sorry. So in problem 1, all numbers less than 9 or greater than 5. There we have the or statement, so we are expecting the word or. That means you can eliminate this one here and that one there, because the one that has the two inequalities but no and or statement is always an and. We can eliminate those two. Our endpoints are 9 and 5. We have both 9s and 5s, but we then need to look at our directions. So we have less than 9. There's our less than sign. But greater than 5. So x greater than 5 and less than 9 would be this one right here. Let's look at 2. Let me erase these so that we don't get confused with the other ones. Number 2, all the numbers that are less than 9 and greater than 5. Well, we know it can't be the first one because it uses the or statement, and we know it can't be the second one because we've already used it. So the last two on column B are both and statements. Which one says that all the numbers are less than 9? Well, here, there's our x representing less than 9. Do you see that statement right there? But x is greater than. Remember, you read it in the direction where you see your x is greater than 5. So number 2 has to be this last one right here. So we have 2 left, and really you could tell which one's which just because of the and or statements. Here we have an and, there we have an or. The only and that we have left is up here, and the only or that, I'm sorry, back up. The only and that we have left is right here, and the only or that we have left is right here. Now we can practice writing compound inequalities. So let's write the phrase in symbols that represents all real numbers that are blank and blank. It says all real numbers that are greater than or equal to -4. So all real numbers, we'll just use x to represent the numbers, that are greater than or equal to -4 and that are less than 6. Part 7. So in this part 7, it's actually just making you do the exact same thing over again that we did. There's no point in really doing this, but if you want to fill it in, it looks like this. See, I just copied down the exact same thing that you were seeing before. Then to graph it, you would look for your endpoints of -4 and 6. All three of those graphs have an endpoint of -4 and 6, but the -4 is closed, so that's closed. This one's open, so it can't be this one here, and this one's closed, so we're good there. We do have an endpoint of 6 that needs to be open. Well, that 6 is open, the 6 is open, so we're still down to the first and the third. But because we have the word and always means in between our two endpoints, so it can't be this one right here. This would be your answer. So the solution of the compound inequality involving and is any number that makes both statements true or false in between the two endpoints.
This right here.
So let's take a look at focus question number 1. It says solve x plus 3 is greater than 2 and x minus 5 is less than 7. When I solve these, I will solve each inequality statement individually before I graph them. So I have x plus 3 is greater than 2. Treat the inequality just like it was almost like an equation. So I need to combine my like terms. I need to move the 3 away from that x. So I write minus 3 on the other side to move that positive 3. X is then greater than positive 2 and negative 3 equals negative 1 because they're opposite signs. So I have to subtract and the bigger sign wins. That inequality statement's finished. I'm ready for the other one. X minus 5 is less than 7. Once again, I need to combine my like terms, so I need to bring that 5 over as a plus 5. So x is less than 7 plus 5. They're same sign, so you just add, is 12. Once we solved each inequality, now it's ready to graph our inequality. Notice that our number line here does not have any numbers on it or any tick marks. Simply what I'll do is I'll draw a tick mark to represent my two endpoints. Well, which number is bigger and smaller? That'll help me decide which way I write it. Negative 1 is smaller than positive 12, so I'm going to write my negative 1 down here and my 12 down here. Those are my two endpoints. I will make a circle to represent those endpoints and color them in if necessary. Neither one of them have the underline underneath, so I do not color either one in. Because the statement has and in it, remember and is in between, so I simply will color my line in between the 2 points. Sometimes you can put a little arrowheads pointing towards each other to show that the two lines would always point in. Alright, so that's what it looks like graphed. Let's take a look at another one. Focus question number 2. This is an OR question. P minus 2 is greater than or equal to 0. Again, I'm going to solve each inequality separately. To get P all by itself, I need to move that 2 over as a plus 2. So P is greater than or equal to 2. And the other statement says P over 10 is less than negative 1. Well, the 10 is under it, so I need to move it up and multiply because it's like saying P divided by 10. So I need to multiply by 10, multiply by 10. The 10's cancel out, and P then would be less than negative 1 times positive 10 is negative 10. So I've solved both inequalities and I'm ready to graph. Again, I make two lines to represent my endpoints. I'll put a circle for each one. The smaller number in this case is the 10, so I'm going to write that on the left and my larger number on the right. Notice that the 2 has the underline under it, so that means it should be a closed circle, so I will color that in. And the statement is an OR statement, so I need to remember that ORs always point opposite directions from one another, so either points away from each other. So that's what the OR statement will look like. Alright, in our third example, here we have a compound inequality. Notice we have two inequality symbols. That's how we know that this is compound. But we notice that there's no words and or. If you do not see the words and or, then it is always an and problem. So this is an and. We do expect that when we graph it, our arrows should be pointing towards each other or in between two endpoints. Sorry, it's not drawing to. Alright, to solve this, you will simply duplicate your middle expression and separate this into two separate inequality symbols. To see what I mean, the first inequality statement uses the first inequality symbol and everything on each side of it. So our first statement is 11 is less than or equal to P plus 9. Your other inequality symbol, or statement, includes that center, everything in the middle, and the second inequality symbol. So either side. So here's the statement, P plus 9, that's a 9, less than 14. So do you see how I've separated the whole statement into made two separate statements? Now I'll solve each statement separately. Alright, I have P plus 9, and I need to move that 9 to the other side as negative 9. So there P is greater than or less than or equal to, so the inequality symbol stays the same direction. 11 minus 9 is 2. It's a positive 2. And our other statement, I've got P all by itself. I can go ahead and leave it that way for now. P plus 9, again, I need to move that 9 over as a negative 9. So P is less than 14 minus 9 is 5. So there's my two statements. that indicate my endpoints of 2 and 5. So I'm going to make 2 circles for my 2 and my 5. 2 smaller than 5, so that's the number I'm going to write on the left endpoint, and the 5 is larger, so I'm going to put it on my right endpoint. Because the P is greater than or equal to, you see the equal to sign, I do color in the 2, but not on the 5 because there's no line underneath the inequality symbol for the P is less than 5. This is an and statement, so I simply color the line in between. One website that you can always go to online is called Khan Academy, Khan Academy, and that's khanacademy.com. And they have all sorts of math topics that they'll have instructors demonstrating to teach you how to solve problems. So let's look at one of the Khan Academy videos.
We're asked to solve for x, and we have this compound inequality here. Negative 16 is less than or equal to 3x plus 5, which is less than or equal to 20. And really there's two ways to approach it, which are really the same way. And I'll do both of them, and I'll actually do both of them simultaneously. So one is to just solve this compound inequality all at once. I'll just rewrite it. Negative 16 is less than or equal to 3x plus 5, which is less than or equal to 20. And the other way is to think of it as two separate inequalities, but both of them need to be true. So you can also view it as negative 16 has to be less than or equal to 3x plus 5, and 3x plus 5 needs to be less than or equal to 20. This statement and this statement are equivalent. This one might seem a little bit more familiar because we can independently solve each of these inequalities and just remember the and. This one might seem a little less traditional because now we have 3 sides to the statement. We have 3 parts of this compound inequality. What we can see is that we're actually going to solve it the exact same way. In any situation, we really just want to isolate the x on one side of the inequality, or in this case, one part of the compound inequality. Well, the best way to isolate this x right here is to first get rid of this positive 5 that's sitting in the middle. So let's subtract 5 from every part of this compound inequality. So we subtract 5 there, subtract 5 there, and subtract 5 over there. And so we get negative 16 minus 5 is negative 21, is less than or equal to 3x plus 5 minus 5 is 3x, which is less than or equal to 20 minus 5, which is 15. And we can essentially do the same thing here. If we want to isolate the 3x, we can subtract 5 from both sides. Subtract 5 from both sides. We get negative 21, and negative 21 is less than or equal to 3x. And we get, subtracting 5 from both sides, and notice we're just subtracting 5 from every part of this compound inequality. We get 3x is less than or equal to 15. So this statement and this statement, once again, are the exact same thing. Now going back here, if we want to isolate the x, we can divide by 3. We have to do it to every part of the inequality. And since 3 is positive, we don't have to change the sign. So let's divide every part of this compound inequality by 3. We divide every part by 3. This is equivalent to dividing every part of each of these inequalities. Every part of these inequalities by 3. And then we get negative 21 divided by 3 is negative 7 is less than or equal to x, which is less than or equal to 15 divided by 3 is 5. You do it here, you get negative 7 is less than or equal to x, and x is less than or equal to 15 over 3, which is 5. This statement and this statement are completely equal. And we've solved for x. We've given you the solution set. And if we want to graph it on a number line, it would look like this. It would look like this is 0, this is 5, this is negative 7. Our solution set includes everything between negative 7 and 5, including negative 7 and 5. So we'll have solid, we have to fill in the circles on negative 7 and positive 5, and it is everything in between. That's our solution set. And so we can verify that these work. You can try out a number that's well inside of our solution set, like 0. 3 times 0 is 0, so you're just left with 5 is greater than or equal to negative 16, which is true, and 5 is less than or equal to 20, or negative 16 is less than or equal to 5, which is less than or equal to 20. So that works. That makes sense. You could try 5. If you put 5 here, you get 3 times 5 plus 5. Well, that's just 20. Negative 16 is less than or equal to 20, which is less than or equal to 20. That works. Negative 7 should also work. 3 times negative 7 is negative 21, plus 5 is negative 16. So you get negative 16, which is less than or equal to negative 16, which is less than or equal to 20. And you could try other values. You could go outside of our solution set. Try something like 10. 10 should not work. And if you see here, if you put 10 here, you get 3 times 10 plus 5 is 35. 35, negative 16 is less than or equal to 35, but 35 is not less than or equal to 20. And that's why 10 is not part of our solution set.
So you can see how Khan Academy, at least you can hear somebody else's voice besides mine, and they will also demonstrate how to do certain types of problems. You can look up any type of problem that you need some additional help with at Khan Academy. Alright, let's take a look at one more problem. Here you have negative 4 minus 5r is greater than or equal to negative 35, or 6r plus 3 is greater than 57. So I'm going to solve each inequality statement independently. Negative 4 minus 5r greater than or equal to negative 39. This is a two-step inequality. I see this negative 4 that's not beside or under my r, so that's what I need to get rid of first. It's negative, so I need to bring it over to the other side. It's a positive 4. That way that'll cancel out. And I will get negative 5r is greater than or equal to negative 39 plus 4. If I combine those two together, they're opposite signs, so I actually have to subtract. 39 is bigger, so therefore the negative stays. 39 minus 4 is 35. Now I still need to get that r by itself. I have a negative 5 that's beside it, so I have to divide by negative 5. Divide by negative 5. What do you need to remember to do when you divide by a negative number? Hopefully you said change the direction of the inequality. So negative divided by a negative is a positive. 35 divided by 5 is 7. So that's one of my endpoints. Now I'm going to write that up at the top here. R is less than or equal to 7. Because I've run out of room to solve my other inequality, I'm going to have to erase for you. If you wrote small enough, or you can write yours off to the side on your paper. Alrighty, so let's solve the other inequality. Six r plus 3 is greater than 57. Again, this is a two-step inequality because we have this constant that's being added to our variable. So to move that to the other side, you need to subtract that 3. And combine like terms. 6r is greater than 57 minus 3 is 54. It stays positive because 57 is bigger than 3. And then you would divide by 6, divide by 6. R's cancel out, so r is greater than 54 divided by 6 is 9. So now we have our two endpoints. This one up here, I don't know where it went to. R is less than or equal to 7, and r is greater than 9. So I'll make my two endpoints. 7's smaller, so it goes on the left. The 9's bigger, so I'll write that on the right. The 7, because that has the equal sign underneath it, is closed, so I colored that in. And the statement is an or, so therefore my arrow should always be pointing away from one another. That's your final focus question or example. Now it's your turn to do the group practice problems on the next page. When you're all done, you can check your work.